Welcome to section 3. In this section we'll cover reinforcement learning and game AI agents. And now we'll cover reinforcement learning. But what I want to convey is the intuition behind the reinforcement learning concepts. So what is reinforcement learning? Reinforcement learning is an agent-oriented learning. So it learns by interacting with the environment to reach a goal. It's more realistic and ambitious and figures out on its own. So you don't give formal training data to reinforcement learning. Rather, the algorithm tries by trial and error and gets a feedback from the environment and figures out what exactly to do. So ultimately, the reinforcement learning algorithm learns by interacting with the environment, which is very good because sometimes you might not have too much of training data. There are different application areas of reinforcement learning. It is applied in optimal control, it is applied in machine learning, it's applied in reward system, operational research, and bounded rationality. In all these different applications, the common key link is getting the feedback from the system based on which the algorithm can learn itself. So what generally a reinforcement learning interface looks like. So you have an agent which does some action in the environment. The environment gives some feedback to the agent that how it did in terms of reward, gain or cost. And the environment also has some state, like which state it is in based on this action. And the ultimate goal of reinforcement learning is to learn the policy which maximizes the reward of the agent in the environment for all possible actions. That's the goal. So how will you identify a reinforcement learning problem? What are the signatures? So in reinforcement learning, for example, the reward is evaluative, meaning that you get some output from the environment and you evaluate it whether the output was good or bad based on your action. Then you take the next action. So if it was bad, so probably you don't do that action. If it was good, so you try to do that action. Thing like this. In reinforcement learning, you also get delayed consequence, meaning that let's say you are in state S and you did some action and you move to the next state, and you again are at state S prime and you do again some action A prime. But now maybe you are receiving the reward for the previous state. In reinforcement learning, it can happen that you receive the reward at a later state. So you have to take into consideration those rewards. And as I said earlier, reinforcement learning is a trial and error method. You have to exploit and you have to explore. But you have in between these two scenarios. Otherwise, your state pace or your action pace can increase too much. And then you will never be able to find the optimal solution in short time or quickly. So you have to be careful about how much you want to exploit and how much you want to explore. So how do you define reinforcement learning formally? We define reinforcement learning formally using Markov decision process, or MDP in short. So in MDP, you have different state and actions. You have some state transition matrix. And as I said, the ultimate goal is to learn the policy, which can be deterministic and stochastic. And the policy is generally denoted by pi. The model is agent's representation of the environment, and the agent tries to find the best discounted policy by the value function. So what exactly is the value function? You write value function in terms of Q, and it's the expected discounted rewards for all the different state and actions. So why discounted? Because let's say you got a reward now, but this reward will have less significance on a state later on. So that's why the rewards are discounted. You can also rewrite the value equation using Bellman's expectation equation as follows. Moving on, we learn about the simplest reinforcement learning algorithm, which is called Qlearning. In Qlearning, first of all, you initialize an array of Q, state and actions arbitrarily. Then you choose the actions in a way based on Q such that all the action and all the states are taken into consideration. And finally, at each time step, you change only one element in Q and only update the element of the array for the state that we just passed out, meaning that we just covered. So that's what it. Let's look at some example, and then this will come back to this equation and hopefully it will be clearer. In this figure, we want to go from state 1 to state 5. Currently, we are at state 1 and we want to go to state 5, and this is our reward matrix, which is denoted by -1 in places where you don't have any connections and you have 0 or 100 or some other values based on the state transitions which we have. So for example, if you want to go from state 1 to state 5, we have a reward of 100. That's written in second row, fifth column. If you look at that position, it is 100. So we are talking about that equation. But let's say you want to go from state 1 to state 5. So first of all, you initialize this queue with zeros. And then what you do, you take 100 as a reward because you are going from 1 to 5. So you have this delta q as alpha into the reward. So we are going from state 1 to state 5. So the reward is 100. And then you take a discounted reward of the next possible state and actions. So from 5, we can go to 1, we can come back to 5 itself, and we can go to 4. So which turns down to Q51, Q54, and Q55. And the maximum of that is 0. So that's how you define this equation at step 3, which I discussed here. That's it. And then you can find out the delta q for each of the different states. And you go on and on until and unless you find the optimal policy, which is the maximum rewards for all the different state and actions. If you want to learn more about reinforcement learning, you can look at the lectures in here. And I hope that I could give you an intuition about the reinforcement learning in this short time. Let's carry on and let's move on to the next topic, which is OpenAI Gym. So why OpenAI Gym? So first of all, how can you evaluate different reinforcement learning algorithms? So there are no standard comparison solutions. So reinforcement learning is a very good sequential decision making process. And if you don't have standardized environments to replicate results from other fellows, you don't know how good your algorithm is doing.